because the engines use the methyl derivatives of hydrogen as a fuel and nitrogen tetroxide as an oxidizer. Because an acronym for Vikram Ambalal Sarabhai is a family of liquid fueled rocket engines conceptualized and designed by Liquid Propulsion System Center since the 1970s. It is used in the Polar Satellite Launch Vehicle PSLV and the Geosynchronous Satellite Launch Vehicle GSLV series of expandable launch vehicles for space land use. Vikas engines are used to power the second stage PSLV boosters and second stage of GSLV Mark 1 and 3, Mark 1 and 2, and now the first stage of GSLV Mark 3, LVM 3. Launch vehicle M3. ISRO obtained liquid engine technology with the help of the French. The Society Européenne de Propulsion, Europe's largest producer of liquid propulsion engine, gave ISRO the technology in return for India's help in developing the French liquid engine, the Viking, and for the parts it made for the Ariane rocket. This technology has been indigenized as the 60-ton thrust Vikas engine, which is used in the second stage of PSLV. Gagan satellite. This is a satellite based augmentation system implemented jointly with Airport Authority of India. This is a satellite based augmentation system SBAS implemented jointly with Airport Authority of India. The main objectives of Gagan are to provide satellite based navigation services with accuracy and integrity required for civil aviation applications and to provide better air traffic management over Indian airspace. Gagan satellite. The main objectives of Gagan are to provide satellite based navigation services with accuracy and integrity required for civil aviation applications and to provide better air traffic management over Indian airspace. The system will be interoperable with the international SBAS systems and provide seamless navigation across regional boundaries. The GPS is core constellation of satellites providing signals from space transmitting position and timing data. The Gagan is an augmentation system which augments the GPS constellation by improving accuracy, availability, continuity and integrity. Gagan consists of set of ground reference stations positioned across various locations in India called the Indian Reference Station, which gather GPS satellite data. A master station, Indian Master Control Center INMCC, collects data from reference stations and create GPS correction messages. The corrected differential messages are uplinked via Indian uplink station and then broadcasted on a signal from 3 geostationary satellites GSAT 8, GSAT 10 and GSAT 15. The information on the signal is compatible with basic GPS signal structure, which means any SBAS enabled GPS receiver can read this signal. Gagan signals can also be used to manage traffic in real time to avoid traffic jams. Applications. Gagan system is being used for effective management of wildlife resources and monitoring of forests using Gagan enabled GPS XXTREO T51. It can provide navigational support to Indian Railway for signaling when train approaches to no man crossing and also for alignment of railway tracks. Road assessment system is likely to be developed for all national highways in the country and a modern management system that will use Gagan system. ISRO's abort missions. The first abort test will be conducted using the special test vehicle TV as a part of Gaganyaan. The abort missions test the systems that can help the crew escape from the spacecraft mid-flight in case of a failure. ISRO has developed test vehicles to send the Gaganyaan systems up to a certain height, then stimulate a failure to check the escape system and fall back into the Bay of Bengal. The escape system is designed with 5 quick acting solid fuel motors with a high burn rate propulsion system along with fins to maintain stability by firing explosive nuts. The crew escape system will separate from the crew module. Essentially, the mission will be conducted to demonstrate the crew escape system in an in-flight abort scenario. The test is called TV Technology Demonstrator 1 TVTD1 mission, which was earlier planned for August, but now it is expected to be carried out in September. Union Minister Jitendra Singh and ISRO Chairman S. Somanath have confirmed the mission. The first abort test will be conducted using the special test vehicle TV as a part of Gaganyaan. The crew module will separate from the TV at a height of around 11 kilometers from sea level, then attain an altitude of around 15 kilometers before falling back in the Bay of Bengal. ISRO's upcoming missions. ISRO's next scientific mission will be the Astronomical Space Observatory EXPOSAT. The EXPOSAT is designed to study cosmic rays and will be India's second astronomical observatory in space after the ASTROSAT. ISRO's first solar mission will be the Aditya L1 mission, in which an Indian spacecraft will travel 1.5 million kilometers from the Earth to the L1 or Lagrangian point between the Sun and Earth. These points between two celestial bodies, the gravitational pull of both bodies is equal to the force required to keep the satellite in orbit without expending fuel. The Aditya L1 will be observe only the outer layers of the Sun called the solar corona. The Aditya L1 will observe, Aditya means Sun. Aditya L1 will observe only the outer layers of the Sun called the solar corona. Indian Regional Navigation Satellite System IRNSS NAVIC. IRNSS is an independent regional navigation satellite system being developed by India. It is designed to provide accurate position information service to users in India as well as the region extending up to 500 km from its boundary, which is its primary service area. An extended service area lies between the primary service area and area enclosed by rectangle from latitude 30 degrees south to 50 degrees north, longitude 30 degrees east to 130 degrees east. IRNSS will provide two types of services, namely Standard Position Service SPS, which is provided to all the users, and Restricted Service, which is an encrypted service provided only to the authorized users. The IRNSS system is expected to provide a position accuracy of better than 20 meters in the primary service area. Three of the 7 satellites are in geostationary orbit (GEOs) and 4 are in geosynchronous orbit (GSO). IRNSS architecture. IRNSS ground segment. The IRNS ground segment consists of ISRO Navigation Center, IRNSS spacecraft control facility, IRNSS range and integrity monitoring stations, IRNSS network timing center, IRNSS CDMA ranging stations. Okay. Emergence of nanotechnology. The earliest evidence of nanotechnology and its application is traced back to 600 BC at Kiladi, India. Subsequently, carbon nanotubes, cementite nanowires were found in the microstructure of wood steel manufactured in ancient India from the period of 900 AD and exported globally. Although nanoparticles are associated with modern science, they were used by artisans as far back as the 9th century in Mesopotamia for creating a glittering effect on the surface of spots. The Japanese scientist called Norio Taniguchi of Tokyo University of Science was the first to use the term nanotechnology in 1974 conference to describe semiconductor process such as the such as thin film deposition and ion beam milling, exhibiting characteristic control on the order of a nanometer. His definition was nanotechnology mainly consists of the processing of separation, consolidation and deformation of materials as one atom or one molecule. However, the term was not used again until 1981 when Eric Drexler, who was unaware of Tanguchi's prior use of the term, published in his first paper on nanotechnology in 1981. The scanning tunneling microscope, an instrument for imaging surfaces at the atomic level, was developed in 1981 by Gerd Beining and Heinrich Rohrer at the IBM Zurich Research Laboratory, for which they were awarded the Nobel Prize in Physics in 1986. Beining, Calvin Coate and Christopher Gerber invented the first atomic force microscope in 1986. The first commercially available atomic force microscope was introduced in 1989. IBM researcher Don Egler was the first to manipulate atoms using a scanning tunneling microscope in 1989. He used 35 xenon atoms to spell out the IBM logo. He shared the 210 Kavli Prize in Nanoscience for this work. Nobel Prize in Physics 2022. The Nobel Prize in Physics 2022 was awarded jointly to Alain Aspect, John F. Clauser and Anton Zellinger for experiments with entangled protons, establishing the violation of Bell inequalities and pioneering quantum information science. Their path-breaking results will have implications in the fields of quantum computers, quantum networks and secure quantum encrypted communication, quantum cryptography and precise timekeeping as is done in atomic clock. Quantum entanglement is the phenomenon where entangled particles remain connected so that actions performed by one affects the behavior of the other. Where distance does not matter, this means that particles are dependent on the other even they are separated by large distances. Hence, quantum teleportation is the only way to transfer quantum information from one system to another without losing any part of it. The teleportation is very sensitive to environmental interference that can be affect its quality or fidelity. Carbohydrates. Carbohydrates are the most abundant class of organic compounds found in living organisms. They originate as produce of photosynthesis and endothermic reproductive condensation of carbon dioxide, requiring light energy and the pigment chlorophyll. Carbohydrates are primarily produced by plants and form a very large group of naturally occurring organic compounds. Some common examples of carbohydrates are cane, sugarcane, glucose, starch, etc. Glucose is the most important source of energy for mammals, is obtained by the digestion of starch. Some of the carbohydrates which are sweet in taste are also called sugars. The most common sugar used in our home is named as sucrose, whereas the sugar present in milk is known as the lactose. Carbohydrates are called saccharides. They are broadly classified into three groups: monosaccharides, disaccharides, and polysaccharides. Monosaccharides a carbohydrate that cannot be hydrolyzed further to give simpler unit of polyhydroxy aldehyde or ketone is called a monosaccharide. Some common examples are glucose, fructose, ribose, etc. Oligosaccharides, carbohydrates that yield 2 to 10 monosaccharides units on hydrolysis are called oligosaccharides. Polysaccharides, carbohydrates which yields a large number of monosaccharide units on hydrolysis are called polysaccharides. Some common examples are starch, cellulose, glycogen, gums, etc. Polysaccharides are not sweet in taste, hence they are also called non-sugars. Cell structure. In animals, neurons lack only cell wall, while the ghost RBCs lack everything except plasma membrane. If the RBCs become swollen in dilute urine to the point that the cell membranes ruptures, the cell loses it has hemoglobin, so that only the membrane and free hemoglobin remain. These empty membranes are known as ghost cells. Fungal cells do not have chloroplast, hence no photosynthesis. Bacteria cells lack nucleus. Their chromosomal DNA resides in a distinct area called protonucleus, which is not separated by a membrane from the rest of the cell, thus it is not termed as nucleus. Twinkling of stars. The twinkling of a star is due to atmospheric reflection of starlight. The starlight on entering the Earth's atmosphere undergoes refraction continuously before it reaches the Earth. The atmospheric refraction occurs in a medium of gradually changing refractive index. Since the atmosphere bends starlight towards the normal, the apparent position of the star is slightly different from the actual position. The star appears slightly higher than its actual position when viewed near the horizon. Since the stars are very distant, they approximate point-sized sources of light. As the path of rays of light coming from the star goes on varying slightly, the apparent position of the star fluctuates and the amount of starlight entering eye flickers. The star sometimes appears brighter and sometimes fainter, which is the twinkling effect. SERB, Science and Engineering Research Board, is a premier funding agency established by the Act of a Parliament SERB Act 2008 to support basic research in frontier areas of science and engineering. SERB Project Information System and Management System PRISM is an attempt by SERB to bring together all the information related to research support extended by SERB over the years and present an integrated and comprehensive view in real time. The website intends to provide a searchable repository containing all project related information for the scientific community and general public. PRISM also provides a platform for the SERB grantees to present their research outcome and achievement to a larger audience. Establishment of PRISM is a significant step forward for SERB in its commitment towards transparency, accountability and dissemination of research outcome originating from SERB funding. PMRF, the Prime Minister's Research Fellows scheme has been designed for improving the quality of research in various higher educational institutions in the country. With attractive fellowships, the scheme seeks to attract the best talent into research, thereby realizing the vision of development. CSIR, the Council of Scientific and Industrial Research, was established by the Government of India in September 1942 as an autonomous body that has emerged as the largest research development organization in India. Although it is mainly funded by the Ministry of Science and Technology, It operates an autonomous body through the Societies Registration Act 1860. The CSIR society comprises eminent scientists, industrialists, and senior officials of scientific ministries. The society meets annually to review CSIR activities and deliberate on its future programs. The Council of Scientific and Industrial Research, known for its cutting-edge research and development knowledge based in diverse S&T, science and technology areas, is a contemporary and research and development organization. CSIR has a dynamic network of 37 national laboratories, 39 outreach centers, 3 innovation complexes, and 5 units with a pan-India presence. CSIR filed about 225 Indian patents and 250 foreign patents per year during 2015 to 20. CSIR has a patent portfolio of 1132 unique patents in force, out of which 142 patents have been commercialized. CSIR also has 2587 in force patents granted abroad in multiple countries. Organization structure: President, CSIR President, Prime Minister as an ex officio member, Vice President, Minister of Science and Technology in India ex officio. Governing body: the Director General is the head of the government body. The other ex officio member is the Finance Secretary. Expenditures: other members' terms are 3 years. CSIR Advisory Board, 15-member body composed of prominent members from respective fields of science and technology. Its functions is to provide S&T inputs to the governing body. Member terms are 3 years. CSIR Jigyasa. The program would be implemented by the Council of Scientific and Industrial Research in collaboration with Kendriya Vidyalaya Sangatan. CSIR Jigyasa. The Jigyasa program is inspired by Prime Minister Narendra Modi's vision of New India and scientific social responsibility of scientific community and institutions. Jigyasa, a student scientist connect program, has been launched by the government in New Delhi. The program would be implemented by the Council of Scientific and Industrial Research CSIR in collaboration with Kendriya Vidyalaya Sangatan. Shanti Swarup Bharatnagar Prize for Science and Technology. Shanti Swarup Bhatnagar SSB Prize for Science and Technology. The award, given annually by the Council of Scientific and Industrial Research, is named after the founder, director, and the Council of Scientific and Industrial Research in India, the late Dr. Sir Shanti Swarup Bhatnagar, and is known as the Shanti Swarup Bhatnagar SSB Prize for Science and Technology. The prize is given each year for outstanding contributions to science and technology. SSB prizes each of the value of 5 lakh rupees are awarded annually for notable and outstanding research applied for fundamental in the following disciplines: biological sciences, chemical sciences, earth atmosphere, ocean and planetary sciences, engineering sciences, mathematical sciences, medical sciences, physical sciences. Any citizen of India engaged in research in any field of science and technology up to the age of 45 years are reckoned on 31st December of the year preceding the year of the prize. The prize is bestowed on a person who is, in the opinion of CSIR, has made conspicuously important and outstanding contributions to human knowledge and progress, fundamental and applied in the particular field of endeavor which is his or her specialization. The prize is awarded on the basis of contributions made through work done primarily in India during the 5 years preceding year over the prize. Hence, it can be given to overseas citizens of India OCI if he or she had worked in India during the 5 years preceding the year of the prize. The prize comprises a citation, a plaque, and cash prize award of 5 lakh rupees. Okay, US dollars 6,600. In addition, recipients also receive the 15,000 rupees per month up to the age of 65 years. Nice. Shanti Swarup Bhatnagar SSB Prize for Science and Technology. Satellites. A geostationary orbit, also referred to as geosynchronous equatorial orbit (GEO), is a circular orbit of 35,786 km in altitude above Earth's equator and follows the direction of Earth's rotation. Satellites in geostationary orbit must all occupy a single ring above the equator. An object in such an orbit has an orbital period equal to Earth's rotational period. One side real day, and so to ground observers it appears motionless in a fixed position in the sky. Communication satellites are often placed in a geostationary orbit so that Earth-based satellite antennas do not have to rotate to track them, but can be pointed permanently at the position in the sky where the satellites are located. Satellites in GEO geosynchronous equatorial orbit cover a large range of Earth, so as few as 3 equally spaced satellites can provide nearly global coverage. This is because when a satellite is this far from Earth, it can cover large sections at once. This is akin to being able to see more of a map from a meter away compared with if you were a centimeter from it. So to see all of Earth at once, GEO geosynchronous equatorial orbit, far fewer satellites are needed than at lower altitude. In order to perfectly match Earth's rotation, the speed of GEO geosynchronous equatorial orbit satellites should be about 3 kilometers per second at an altitude of 35,076 kilometers. This is much farther from Earth science compared to many satellites. Special theory of relativity. Modern relativity is based on Einstein's two postulates. The first postulate of special relativity is the idea that the laws of physics are the same and can be stated in their simplest form in all inertial frames of reference. The second postulate of special relativity to the idea that the speed of light c is a constant independent of the relative motion of the source. Evidence for evolution comes from many different areas of biology: anatomy, molecular biology, biogeography, fossils, direct observation. Anatomy: species may share similar physical features because the feature was present in a common ancestor, homologous structures. Molecular biology: DNA and the genetic code reflect the shared ancestry of life. DNA comparisons can show how related species are. Biogeography: the global distribution of organisms and the unique features of island species reflect evolution and geological change. Fossils document the existence of now extinct past species that are related to present day species. Direct observation: we can directly observe small scale evolution in organisms with short life cycles. Example: pesticide resistant insects. Chemicals in everyday life. Tranquilizers are prescribed for anxiety, acute stress reactions and panic attacks. Commonly known as medications include Xanax, Valium, Clonopin and Ativan. Equinol was also as a tranquilizer. Naproxen is analgesic, while tetracycline and chlorpheniramine are antibiotics. Diphenhydramine also blocks the action of acetylcholine and is used as a sedative because it causes drowsiness. Omeprazole is a proton pump inhibitor. It works by decreasing the amount of acid produced by the stomach. Chemical bonding. Chemical bonds are what hold atoms together to form the more complicated extended solids. Mainly 3 types of bonds can be present in chemical compounds. Extravalent or ionic bond, it is formed by transferring of electrons between 2 atoms. These types of bonds are mainly formed between metals and non-metals. These compounds exist in solid form. These compounds have high boiling point, melting point and thermal stability. Covalent bond, it is formed by equal sharing of electrons between 2 atoms. This type of bond is mainly formed between non-metals. These compounds may be solid, liquid or gas. These compounds have low boiling point, melting point and thermal stability in comparison to ionic bond. Thermodynamics. The laws of thermodynamics deal with energy changes of microscopic systems. involving a large number of molecules rather than microscopic systems containing a few molecules. Laws of thermodynamics apply only when a system is in equilibrium or moves from one equilibrium state to another equilibrium state. Macroscopic properties like pressure and temperature do not change with time for a system in equilibrium state. The zeroth law of thermodynamics states that if two bodies are each in thermal equilibrium with the third body, then they are also in equilibrium with each other. Isotopes. Isotopes are members of family of an element that all have the same number of protons but different number of neutrons. All elements have isotopes. There are two main types of isotopes, stable and unstable. The first 80 elements on the periodic table have stable isotopes. The properties of stable isotopes allow them to be used to understand and manage water to land resources. They are also used in environmental studies, nutrition assessments and forensics. There are 254 known stable isotopes. All artificial isotopes are unstable and therefore radioactive. Scientists call them radioisotopes. There are more than 3000 known radioisotopes. They are unstable from an element which emit different layers of radiation, which makes them useful in medicine, industry, agriculture, radiopharmaceutical sciences, industrial applications, environmental tracing and biological studies. Some elements can only exist in an unstable form. For example, uranium. Hydrogen is the only element whose isotopes have unique names. Deuterium for hydrogen with 1 neutron and tritium for hydrogen with 2 neutrons. Nucleons. The nuclei of atoms are made up of protons and neutrons. These are two components of the nucleus are referred to as nucleons, and their total number is known as mass number of an atom. The mass of molecules is less than the sum of individual masses of the protons and neutrons. The difference is the measure of binding energy per nucleon that holds the nucleons together. Contribution of biotechnology in the field of crop production. Biotechnological tools that have greatly contributed to the production and supply of improved quality seed and planting material to farmers worldwide. Among other uses, biotechnology is employed to speed up the multiplication process for vegetatively propagated crops, detect diseases transmitted by seed or planting material, eradicate diseases transmitted by planting material, protect seed with biological control agents and test varietal identity and purity, crop biofortification, weedside resistance crops, organic farming, hybrid varieties, fragrant mango varieties, organic farming. Although the crops and farming practices can be further improved using biotechnology, organic farming has been practiced by farmers across the world even before the emergence of the field of biotechnology. Hybrid varieties. These are improved varieties of the crops made by the use of existing germplasm using conventional breeding and selection for the desired traits. Fragrant mango varieties. These varieties of the mango, their fruits contain volatile substances that cause a specific type of aroma from different varieties. These are mostly naturally occurring traits, and some varieties have been developed by breeding of the two existing varieties. Embryo transfer technology. To maintain the titopotency of the blastomeres in vitro condition, a special non-differentiating medium is needed. Applications of embryo transfer technology. In humans for treating infertility, IVF and embryo transfer is needed in cases of where natural fertilization is an option for or has difficult occurring. There are mainly reasons for embryo transfer, including ovulation disorders, damaged fallopian tubes, endometriosis, premature ovarian failure, genetic disorders, uterine fibroids, impaired sperm production. Creating better breed of animals more quickly. The superior female can produce a large number of ova in a very short amount of time, which a superior male and female have been chosen. These embryos can be given to any host female of the same species after being fertilized by semen obtained from the chosen male. In contrast to the natural technique, which produces to a produce maximum of one calf per pair per year. For example, in the case of cows, we can get approximately 10 to 20 calves of the superior male female in a year using this method. To increase the population of wild animals for the sake of conservation, and the same strategy might be used. Embryo transfer technologies. Drug formulation, also known as pharmaceutical formulation, is the process through which a variety of substances called inactive excipients are combined with the drug's active pharmaceutical ingredient to finally produce a drug product can be successfully given to patients. The development of a drug's formulation is crucial to its success. Stability and bioavailability problems are just two examples of formulation related difficulties. A drug product's biologically active ingredient, also known as bulk medication or active pharmaceutical ingredient API, is what causes the desired effects. One common medicine that serves to treat pain is paracetamol. To create a completed paracetamol product, such as a paracetamol tablet, capsule or syrup, which the patient consumes, it is combined with binding agents or solvents. India's pharmaceutical sector is one of the biggest in the world, third largest by volume, yet it imports a lot of APIs from other nations, especially China. The 2030 Agenda for Sustainable Development recognizes NCDs as a major challenge for sustainable development. International Nuclear and Radiological Event Scale. The International Nuclear and Radiological Event Scale is a tool for communicating the safe significance of nuclear and radiological events to the public. Member states uses INES in a voluntary basis to rate and communicate events that occur within their territory. It is not a notification or reporting system to be used in emergency response. INES covers events at facilities and activities involving radiation sources. It is used for the rating of events that result in a release of radioactive material into the environment and in the radiation exposure of workers and the public. It is also used for events that have no actual consequences, but where the measures put in place to prevent them did not function as intended. The scale is also applied to events involving the loss or theft of radioactive sources and the discovery of uncontrolled radioactive sources in scrap metal. INES should not be used to rate events resulting from procedures where people are intentionally exposed to radiation as part of a medical treatment. INES is intended for use in non-military applications and only relates to the safety aspects of an event. INES should not be used to accessing or comparing safety performance between facilities, organizations or countries. It also should not be used to trigger emergency response actions. Probiotics are live microorganisms, bacteria and yeast that are intended to have health benefits which consumed or applied to the body. They are found in yogurt and other fermented foods, dietary supplements, and beauty products. Probiotics may contain a variety of microorganisms. The most common are bacteria that belong to group are called Lactobacillus bifidobacterium. Other bacteria may also be used in probiotics, and so may yeast such as Saccharomyces bowler. The prebiotics are not same as probiotics. Prebiotics are non-digestible food components that selectively stimulate the growth or activity of desirable microorganisms. Symbiotics are products that combine probiotics and prebiotics. Probiotics might help body maintain a healthy community of microorganisms and help your body community of microorganisms return to a healthy condition after being disturbed and produce substances that have desirable effects and influence body's immune responses. Megaloblastic anemia. Megaloblastic anemia encompasses a heterogeneous group of macrocytic anemias characterized by the presence of large red blood cells precursors called megaloblasts in the bone marrow. This condition is due to impaired DNA synthesis, which inhibits nuclear division, cytoplasmic maturation, mainly independent to RNA and protein synthesis is less impaired. This leads to an asynchronous maturation between the nucleus and the cytoplasm of erythroblasts, explaining the large size of megaloblasts. The process affects hematopoiesis as well as rapidly renewing tissues such as gastrointestinal cells. Megaloblastic anemia is most often due to hypovitaminosis, especially vitamin B12 and folate deficiencies, which are necessary for the synthesis of DNA, copper deficiency, and adverse drug reactions due to drug interference with DNA synthesis are other well-known causes of megaloblastic anemia. A rare hereditary disorder known as thiamine responsive megaloblastic anemia syndrome is also identified as a cause of megaloblastic anemia. The list of drugs associated with the disease is long. However, frequently implicated agents include hydroxyurea, chemotherapeutic agents, anticonvulsants, and antiretroviral therapy drugs. Pernicious anemia. Pernicious anemia is a drug decrease in red blood cells that occurs when the intestines cannot properly absorb vitamin B12. Causes. Pernicious anemia is a type of vitamin B12 anemia. The body needs vitamin B12 to make red blood cells. We get this vitamin from eating foods such as meat, poultry, shellfish, eggs, and dairy products. A special protein called intrinsic factor binds vitamin B12 so that it can be absorbed by the intestine. This protein is released by the cells in the stomach. When the stomach does not make enough intrinsic factor, the intestine cannot properly absorb vitamin B12. Common causes of pernicious anemia: weakened stomach lining, atrophic gastritis, an autoimmune condition which in which the body's immune system attacks the actual intrinsic factor protein or the cells in the lining of your stomach that makes it anemia. Okay. Down syndrome is a chromosomal condition that is associated with intellectual disability, a characteristic facial appearance and weak muscle tone in infancy. All affected individuals experience cognitive delays, but the intellectual disability is usually mild to moderate. People with Down syndrome often have a characteristic facial appearance that includes a flattened appearance to the face, outside corners of the eyes that point upward, small ears, a short neck, and a tongue that tends to stick out of the mouth. Affected individuals may have a variety of birth defects. Many people with Down syndrome have small hands and feet and a single crease across the palms of the hands. About half of all affected children are born with a heart defect. Digestive abnormalities such as blockage of the intestine are less common. Individuals with Down syndrome have an increased risk of developing several medical conditions. These include gastroesophageal reflux, which is a backflow of acidic stomach contents into the esophagus, and the celiac disease, which is an intolerance of a wheat protein called gluten. About 15% of people with Down syndrome have an underactive thyroid gland, hypothyroidism. The thyroid gland is a butterfly shaped organ in the lower neck that produces hormones. Individuals with Down syndrome also have an increased risk of hearing and vision problems. Additionally, a small percentage of children with Down syndrome develop cancer of blood forming cells, leukemia. Delayed development and behavioral problems are often reported in children with Down syndrome. Affected individuals can have growth problems and their speech and language develop later and more slowly than in children without Down syndrome. Additionally, speech may be difficult to understand in individuals with Down syndrome. Behavioral issues can include attention problems, obsessive or compulsive behavior, and stubbornness or tantrums. Most causes of Down syndrome result from trisomy 21, which means each cell in the body has 3 copies of chromosome 21 instead of the usual 2 copies. A very small percentage of people with Down syndrome have an extra copy of chromosome 21 in only some of the body cells. In these people, the condition is called mosaic Down syndrome. N-power policy of India. India has a 3-stage nuclear power program. Second stage of nuclear power generation envisages the use of Pu-239 obtained from the first stage reactor operation as the fuel core in fast breeder reactors. India has consistently proceeded to explore the possibility of tapping nuclear energy for the purpose of power generation. In this direction, a 3-stage nuclear power program was formulated by Homi Bhabha in the 1950s. Stage 1, pressurized heavy water reactor uses natural UO2 oxides of U235 and 238 as fuel matrix, heavy water as moderator and coolant. In the reactor, the first 2 plants were of boiling water reactors based on imported technology. Subsequent plants are of PHWR type of through indigenous R&D efforts. India achieved complete self-reliance in this technology, and this stage of the program is in the industrial domain. The future plan includes the setting up of VVER type, that is Russian version of the pressurized water reactor, is under progress to augment power generation. MOX fuel was developed and introduced at Tarapur to conserve fuel and develop new fuel technology. Second stage of nuclear power generation envisages the use of Pu-239 obtained from the first stage reactor operation as the fuel core in fast breeder reactors. Third phase of India's nuclear power generation program is breeder reactors using U-233 fuel. In India's vast thorium deposits permit design and operation of U-23 fueled breeder reactors. Applications of microbial enzymes in food industry: amylase, glucoamylase, protease, lactase, lipase, cheese, phosphorylase, esterase, lipase, phosphorylase, esterase, cellulase, xynolase, pectinase, lactase, catalase, peroxidase, acetolactate, amylase, baking, brewing, starch, liquefaction, bread quality improvement, rich cakes, etc. Glucoamylase, beer production, bread quality improvement, high glucose and high fructose syrups. Lactose intolerance reduction in people, prebiotic food ingredients. Lipase, cheese flavor development, cheddar cheese production. Lactase, polyphenol removal of the wine baking. Okay. Cellulase, animal feed, clarification of fruit juice. Xynolase, clarification of fruit juice, beer quality improvement. Pectinase, clarification of fruit juice. Glucose oxidase, food shelf life improvement, food flavor improvement. Esterase, enhancement of flavor and fragrance in fruit juice. Deesterification of dietary fiber, production of short chain flavor esters. Application of environmental biotechnology. Environmental biotechnology is the branch of biotechnology that addresses environmental problems such as the removal of pollution, renewable energy generation or biomass production by exploiting biological process. The advantages of biotechnological treatment of wastes are as follows: biodegradation or detoxification of a wide spectrum of hazardous substances by natural microorganisms, availability of a wide range of biotechnological methods for complete destruction of hazardous waste, and diversity of the conditions suitable for biodegradation. The main consideration for the application of biotechnology in waste treatment are technically, economically reasonable rate of biodegradability or detoxification rate of substances during biotechnological treatment, big volume of treated waste, and ability of natural microorganisms to degrade substances. Biosensors including immunosensors, aptasensors, genosensors and enzymatic biosensors have been reported for the detection and monitoring of various environmental pollutants using antibodies, apatometers, nucleic acids and enzymes as recognition elements respectively. The Department of Atomic Energy. The Department of Atomic Energy came into being on August 3, 1954 under the direct charge of the Prime Minister through a presidential order. According to the resolution constituting AEC, the atomic under the resolution constituting AEC, the Secretary to the Government of India in the Department of Atomic Energy is ex officio chairman of the Atomic Energy Commission. Secretary to the Government of India is in the Department of Atomic Energy is the ex officio chairman of the Atomic Energy Commission. The Atomic Energy Commission AEC. DAE, Department of Atomic Energy, has been engaged in the development of nuclear power technology, applications of radiation technologies in the fields of agriculture, medicine, industry and basic research. DAE comprises 5 research centers, 3 industrial organizations, 5 public sector undertakings and 3 service organizations. It has its aegis 2 boards for promoting and funding extramural research in nuclear and allied fields. It also supports 8 institutes of international repute engaged in research in basic sciences, astronomy, astrophysics, cancer research and education. It also has in its fold is an educational society that provide educational facilities for children of DAE employees. Effects of radiation. UV radiation generates ground level ozone O3 and some particulate matter PM, frequently called aerosol, that include nitrate, sulfate and organic aerosols causing adverse effect on human health and the environment. UV promotes the formation of hydroxyl radicals that act as cleaning agents for troposphere. The radicals restrict the lifetime of many gases like methane, HFCs, CFCs, sulfur and nitrogen oxides that are important to tropo and stratosphere and control the climate change. The exposure to UV radiation has both benefits and risks for human health. The best defined direct benefit is the synthesis of vitamin D from cholesterol. Some of the indirect benefits include change in food quality and disinfection of surface drinking water. The depletion of ozone shell has led to an enormous increase in input of solar UVB radiation penetrating its surface, causing major penalties for human health. Radiation doses are commonly expressed in millisieverts. International units are REM, US units. A dose can be determined from a one-time radiation exposure or from accumulated exposure over time. Intensified Mission Indradhanush 3.0. Recently, Intensified Mission Indradhanush 3.0 was launched by India. IMI 3.0. The campaign is aimed to reach those children and pregnant women who have been missed out left the routine immunization program. This is aimed to accelerate the full immunization of children and pregnant women through a mission mode intervention. In Intensified Mission Indradhanush 3.0, the government has placed a strong emphasis on COVID-19 appropriate behavior because of the pandemic. For this program, the districts have been classified to reflect 313 low risk, 152 medium risk, 250 high risk districts. It is successive to Universal Immunization Program launched in 1985, which was modified in 2015. A mission Indradhanush to rapidly increase the full immunization coverage to 90%. Full immunization coverage to 90%. Diphtheria, whooping cough, tetanus, polio, tuberculosis, hepatitis B, meningitis and phenomena, hemophilus influenza type B infections, Japanese encephalitis, rotavirus vaccine, pneumococcal conjugate vaccine and measles rubella. Okay, it provides vaccination against 12 vaccine preventable diseases which include drug pricing in India. As per the WHO, essential medicines are those who that satisfies the priority healthcare needs of the population. Such medicines are intended to be available in inadequate amounts, inappropriate dosage, forms and strength with assured quality. The WHO's essential medicine list is a model list and is not binding on any country. The decision about which medicines are essential remains a national responsibility based on country's disease burden, priority health concerns, affordability concerns, etc. In India, the Ministry of Health and Family Welfare has been releasing national list essential medicines since 1996. NLEM list is revised and the ceiling prices are fixed every 5 years. NLEM 2015, which was implemented from 2016, has ended in March 2021. Indian government brought it in a new system of drug price control. Under this system, the Health Ministry prepare a list of drugs eligible for price regulation, which the Department of Pharmaceuticals, which comes under the Ministry of Chemicals, Fertilizers, incorporates them into Schedule 1 of Drug Pricing Control Order. The Drug Prices Control Order 1995 is an order issued by the Government of India under Section 3 of Essential Commodities Act 1955 to regulate the prices of drugs. The Standing Committee on Affordable Medicines and Health Products will advise the drug price regulator, the NPPA, on vetting the list. The National Pharmaceutical Pricing Authority then fixes the prices of drugs in this schedule. Yellow fever, liver attenuated virus, hepatitis B, protein subunit of virus, diphtheria, inactivated tetanus toxins, pneumococcal, carbohydrate or carbohydrate conjugates. Vaccines can be classified into two broad groups: live attenuated vaccine, subunit vaccines. Live attenuated vaccines consist of weaker strains of the pathogens. These resemble the kind of innate immunity that people who survive live infection develop. Examples of this live attenuated virus. Okay. Examples of this type of include immunizations against acute disease brought by variant pathogens such as smallpox, yellow fever, measles, mumps, rubella, and chickenpox. Live attenuated vaccines have been given to billions of people all over the world. They frequently offer protection that lasts for several decades with just a single inoculation and elicit significant cellular and antibody responses. Any vaccine must improve on what nature has evolved because many acute infections such as those caused by the respiratory syncytial virus and malaria do not produce full protection against reinfection. Furthermore, pathogens that rapidly evolve like HIV have numerous serotypes like dengue virus or produce latent or persistent infection like HIV and hepatitis C virus present significant immunological problems. Okay. Subunit vaccines contains a part of pathogen that can invoke an immune response in the recipient and confers future immunity through memory cells. Protein subunit such as the vaccine against the recombinant hepatitis B. Toxoid vaccines consist of inactivated toxins, example vaccines against diphtheria and tetanus. Carbohydrate vaccines such as vaccines against pneumococcus. Conjugate vaccines such as vaccines against Haemophilus influenza type B or meningococcus. Such vaccines usually contain substances called adjuvants which enhance the magnitude and modulate and qualify the immune response. Mitochondrial DNA, mtDNA and paleogenetics. Mitochondria are located out the nucleus and cytoplasm of the cells. They play a central role in cell life and death. They have small genome independent of the nuclear DNA. Mitochondrial DNA are circular double-stranded molecules with high copy number and a higher evolutionary importance compared to nuclear DNA. They have specific uniparental inheritance only from mothers to their child, which is usual for tracing matrilineal kinship in many generations. Mitochondrial DNA is a proper tool for determination of the origin of different populations. It is an important object of study in different fields such as evolutionary anthropology, population genetics, medical genetics, genetic genealogy, and forensic science. Mitochondrial DNAs are not involved in recombinant process and their variants are due only to mutations. Golden rice contains genesis from Narcissus pseudo Narcissus. Okay. GMOs in agriculture. Genetically modified foods were first approved for human consumption in the United States in 1994. By 2014 to 15, about 90% of the corn, cotton, and soya beans planted in the United States were GM. By end of 2014, GM crops covered nearly 1.8 square kilometers of land in more than 2 dozen countries worldwide. The majority of GM crops were grown in the America. Engineered crops can dramatically increase per area crop yields and in some cases reduce the use of chemical insecticides. For example, the application of wide spectrum insecticides declined in many areas growing plants such as potatoes, cotton, corn that are endowed with a gene from the bacterium Bacillus thuringiensis which produces a natural insecticide called Bt toxin. Field studies conducted in India in which Bt cotton was compared with non-Bt cotton demonstrated a 30 to 80% increase in yield from the GM crop. This increase was attributed to market improvement in the GM plant's ability to overcome bollworm infestation which was otherwise common. Genetic modification of insects has become an important area of research, especially in the struggle to prevent parasitic diseases. For example, GM mosquitoes have been developed that express a small protein called SM1 which blocks entry of the malaria parasite. Plasmodium into the mosquitoes this results in the disruption of the parasite's life cycle and renders the mosquito malaria resistant. Introduction of these GM mosquitoes into the wild could help reduce transmission of the malaria parasite. In other example, male as male Aedes aegypti mosquitoes engineered with method known as the sterile insect technique transmit gene to their offspring that causes the offspring to die before become sexually mature. mRNA, tRNA, or RNA. RNA types and functions. Three main types of RNA are involved in protein synthesis. They are messenger RNA and transfer RNA, tRNA, and ribosomal RNA or RNA. mRNA, messenger RNA, is transcribed from DNA and contains the genetic blueprint to make proteins. Prokaryotic mRNA does not need to be processed and can proceed to synthesize proteins immediately in eukaryotes. A freshly transcribed RNA transcript is considered a pre-mRNA and needs to undergo maturation to form mRNA. A pre-mRNA contains non-coding and coding regions known as introns and exons respectively. During pre-mRNA processing, the introns are spliced and the exons are joined together. Introns are spliced and exons are joined together. tRNA, transfer ribonucleic acid, is a type of RNA molecule that helps decode a messenger sequence into a protein. tRNA functions at a specific sites in the ribosome during translation, which is a process that synthesizes a protein from an mRNA molecule. There are no tRNA carrying the complementary sequence for the stop codon. The absence of tRNA triggers the termination translation progress. The recombinant DNA technology. To make it stable stay in the cell, DNA fragment needs to be integrated with chromosomal DNA at a suitable case. Recombinant DNA technology. The technology used for producing artificial DNA through the combination of different genetic materials from different sources is referred to as recombinant DNA technology. Recombinant DNA technology is popularly known as genetic engineering. The recombinant DNA technology emerged with the discovery of restriction enzymes in the year 1968 by Swiss microbiologist Werner Arber. Inserting the desired gene into the genome of the host is not as easy as it sounds. It involves the selection of the desired gene for administration into the host, followed by selection of the perfect vector with which the gene has to be integrated and recombinant DNA formed. Thus, the recombinant DNA has to be introduced into the host, and at last it has been maintained in the host and carried forward to the offspring. Releasing the organisms carrying foreign genes in the wild can have disastrous outcome in the term of ecosystem, but if the genes give any sort of survival advantage of the organism, it will certainly increase the survival of the individuals carrying the gene and certainly enrich the gene pool of the species. Applications of DNA sequencing. Molecular biology, evolutionary biology, metagenomics, virology, medicine, forensic investigation. DNA sequencing may be used along with DNA profiling methods for forensic identification and paternity testing. DNA testing has evolved tremendously in the last few decades to ultimately link a DNA print to what under investigation. The DNA patterns in fingerprint, saliva, hair follicles, etc. unique separate each living organism from another. Testing DNA is a technique which can detect specific genomes in a DNA standard to produce a unique and individualized pattern. Applications of DNA sequencing. Applications of DNA sequencing. Pathogens and vectors. Pathogens and vectors. Dengue, malaria, Chagas, Leishmaniasis, chikungunya, onchoriasis, West Nile encephalitis. Dengue, a potentially lethal disease transmitted through the bites of infected mosquitoes. Pathogen, dengue virus. Vector, Aedes aegypti mosquito. Malaria caused by the Plasmodium parasite transmitted through bites of Anopheles mosquitoes. Chagas is a parasitic disease caused by the T. cruzi and transmitted mainly through the bites of so-called kissing bug. Pathogen, Trypanosoma cruzi. Leishmaniasis is caused by protozoan parasite Leishmania transmitted through mosquito bites. Leishmania. Vector, Plebotum sp sandfly. Yellow fever, an acute viral hemorrhage disease transmitted by infected mosquitoes. Pathogen, yellow fever virus. Vector, Aedes aegypti. Chikungunya is a viral disease transmitted by mosquitoes. Chikungunya. Pathogen, chikungunya virus chickpea. Vector, Aedes aegypti, Aedes albopictus. Effects of biodiversity and disease transmission. Effects of biodiversity and disease transmission. Effects of biodiversity and disease transmission. The loss of biodiversity can affect the transmission of infectious disease by changing the abundance of the host or vector, the behavior of the host. Civil applications of nuclear energy. The Food and Agriculture Organization FAO of the United Nations estimates that about 795 million people were suffering from chronic undernourishment in 2014 to 16. Radioisotopes and radiation used in food and agriculture are helping to reduce these figures as well as directly improve food production. Agriculture needs to be sustainable over the long term. The FAO works with IAEA on programs to improve food sustainability assisted by nuclear and related biotechnologies. Potable water is a majority priority in sustainable development where it cannot be obtained from streams and aquifers. Desalination of seawater, mineralized groundwater or urban wastewater is required. Most desalination today uses fossil fuels and thus contributes to increased levels of greenhouse gases. The feasibility of integrated nuclear desalination plants has been proven with over 150 reactor years of experience, chiefly in Kazakhstan, India and Japan. Large-scale deployment and nuclear desalination on a commercial basis with reactors built primarily for that purpose will depend on economic factors. Radiation is used to control insect population via the sterile insect technique. Radioisotope play an important role in detecting and analyzing pollutants. Advantages of nuclear energy: low pollution, high power outputs, stable base load energy, low operating cost. Disadvantage of nuclear energy: environmental impact, radioactive waste disposal, high cost, uranium is finite. Advantages of nuclear energy: low pollution. Nuclear power also has a lot fewer greenhouse emissions. It has been determined that the number of greenhouse gases have decreased by almost half because of the prevalence in the utilization of nuclear power. Environmental impact: the process of mining and refining uranium has not been clean. Actually, transporting nuclear fuel from plants involves pollution hazard. Radioactive waste disposal. A nuclear power plant creates 20 metric tons of nuclear fuel per year, and with that comes a lot of nuclear waste. High cost. Despite being relatively inexpensive to operate, nuclear power plants are incredibly expensive to build. In addition to the expense of building a power plant, nuclear power plants must also allocate funds to protect the waste they produce and keep it in cooled structures with security procedures in place. Uranium is finite. Typical renewable energy sources such as solar, wind are in infinite supply. Nuclear energy is not a renewable fuel source. The fuel to power output ratio for nuclear energy is incredibly high. A relatively small amount of uranium can be used to fuel a 100 megawatts electric plant, thus providing enough electricity to power a city of about half a million people. The stable production of power created by nuclear power plants means that it can ideally be used in conjunction with other forms of renewable energy. Nuclear power produces very inexpensive electricity and is cheaper than gas, coal, and any other fossil plants.